All right, so we're going to take a look at the examples that go with this first derivative test stuff here. So finding the local max and local min, where they occur, all that fun stuff. So let's see, on 219. All right, so in exercise 1 through 6, use the first derivative test to determine the local extreme values of the function. Identify any absolute extrema. Support your answers graphically. I do not care about the graphically part of that. You can literally just put the graph or the function in your calculator and graph it, and you can be like, oh, yep, there it is. So I'm just going to label these the first derivative test questions. So number 2, y equals negative 2x cubed plus 6x squared minus 3. So we're going to take the derivative, set it equal to 0, and find our zeros of that first. So what is the derivative of this? And then I want to set this equal to 0, so I'm going to pull out the thing that's in common. So I'm going to pull out I'm going to take out the negative with it. So negative 6x, and then that leaves me with x minus 2. And then we're going to set that equal to 0. So I would have that negative 6x equals 0, or x minus 2 equals 0. So x equals 0 or x equals 2. So then we're going to do a sign chart for this one. The key thing is when you make the sign charts for these different tests is keeping up with what you're plugging the values into that you're looking at. So for this one, we put the zeros on here. So 0 and 2. So we're going to evaluate with the different points that are between this region, okay? So the thing to note is that we're plugging this in to y prime. So we want the sign of y prime when we're looking at that value, okay? Sign of, I don't know why I wrote it up backwards like that. Sign of y prime is what we're dealing with here. So when I plug, let's say negative 1, because that's a number over in this region, that's easy. When I plug negative 1 in up here, is my result going to be positive or negative? A negative 1. So if I did, yeah, because this is going to be negative 6 minus 12, so it's going to be negative. So, and I don't care what the number is, I just care if it's positive or negative. And I always try to pick the easiest number. So again, in this middle region, I'm going to pick 1. So if I plug in a positive 1 to y prime, what do I get sign-wise? So it'd be negative 6 plus 12, so it would be positive, right? So positive. And then over here, if I plug in a positive 3, let's see, negative 6 times 9 plus 36, that's what, like negative 54 plus 36. So negative. So we want to know at these points, are they local max or min? So that's what we're trying to figure out. So by this, when we change from negative to positive, so from going down to going up, okay, is that a min or a max? So if I was going down and then I switched to going up, is that a min or a max? Okay, that's a min. So we have a local min. no, you're good. At x equals 0. And we're going to leave a little bit of space over here because we're going to look at something else over here in just a second. And then when it goes from positive to negative, we have a max. So a local max at x equals 2. So then what we do is we plug these numbers into the original equation, okay, and then we're going to figure out what the xy coordinate of that is, where that occurs. So f of 0, so if we plug in 0 up here, I'm left with -3. So the actual point would be at 0, -3, where the min occurs. And then f of 2, if I plug in 2, I have, what's this, 8, 16, -16 plus 24. So what is that? Positive 8 minus 3, 5. Is that what y'all got? I think. So then 2, 5 would be the point where that actually occurs. So technically, let me see which way they actually want you to write it, because in technicality, you could do it either way. So let me see how they actually have you writing them, just so that we're consistent here. 5.3, right? 5.3. That's still not 5.3. Okay. Number 2. So they officially want these values here, so they actually would want you to say a local min at the point and then a local max at the point. But if you'd write it across like this, like, I'm okay with that too. So, but just if you go to check your answers, they're looking for these officially. All right, let's look at another one. Number 4. So same instructions. This time we have y is equal to xe to the 1 over x. So this derivative is going to be a little bit different, obviously, because we have the e to the 1 over x with it. So if I take the derivative of this, I have a product rule. So what does this derivative give me?
E to the quarter x, I don't know what this is. Plus x 1 over x. Wait.
You can just tell me in the order that you would actually do the chain rule, and then I'll. So the derivative of e to the x is what?
You bring that to the front,
No, the derivative of e to the x is just e to the x. And then since this is a chain rule, we're going to also take the derivative of the top. So it's just going to be x e to the 1 over x times the derivative of 1 over x. You can use the quotient rule, or eventually you'll just get used to it. It's negative x to the negative 2. So the derivative of the second part, we copy down the first thing. E to the x, whatever, or e to the u, is you copy that down for the derivative, and then you take the derivative of u, which is the derivative of 1 over x, which is this. So then I can rewrite this if I want as e to the 1 over x minus Now, technically, this here is the same thing as negative 1 over x squared. So an x and that is going to cancel. So I'm going to be left with on top e to the 1 over x over x on the bottom. And then I'm obviously wanting to find the 0, so if I can take something out, I want to do that. So since this e to the 1 over x is all on the top of this fraction, along with this, I can take one of them out. So e to the 1 over x times, taking that one away, I'm left with 1, minus, taking that one away, I'm left with 1 over x. So then I can set this equal to 0. And solve it. Is there any way for e to the 1 over x to be equal to 0? Technically. Can you divide by 0? It's going to give you a trick question. No, you can't divide by 0. So basically, there's nothing you can really do with that because there's pretty much no way for that to be equal to 0 because, well, actually, pause. That may not be true. No, hello. E to the 1 is just e. I don't know what I was thinking. Never mind, ignore whatever I was just saying. Okay, so then we would have this 1 minus 1 over x is equal to 0. So I could subtract the 1. So negative 1 over x is equal to negative 1. I want to get the x on the top. So technically, I could treat the right side as negative 1 over 1. So I can flip it over, essentially, giving you negative x is equal to negative 1. Still, in reality, negative divided by negative, so x is going to be equal to 1. So I'm looking at it at the point where no, because I just literally did this. So I'm treating this as that. And so then I just took it and flipped it. So, I mean, I could have done it all in one step if I wanted to and just have gone ahead and taken the negative away. So, I mean, I guess technically what you're saying, yes, is true. Just, yeah, it doesn't matter. So then sign chart for this. So at 1, now I'm going to write this down here again just so that we have it. And again, I'm looking at the sign of f prime. I always like to write what I'm looking for because when we get to the second derivative test, we're plugging it into the second derivative of it. And so sorry, I'm going to confuse you. When we get to the concavity stuff, we're plugging it into the second derivative. So I always like to put what I'm plugging it into just so that I don't get confused because speaking from experience, it happens a lot. I'll like go to plug it in somewhere and I'm like, oh, that's not what I'm supposed to be doing. So if I plug in 0 to this, I can't plug in 0. Do negative 1 instead. It'll be easier. Technically 0 doesn't work for the function, but it, yeah, anyways. So it'll make it 0. plug in -1 because a 0 is going to give you a dividing by 0. So
Yeah.
technically speaking, you can't have 0, so you could list this down if you wanted to. Because you can't have it, but you wouldn't get that from this, if that makes sense. So if you plug in -1, what do we get? Sign-wise.
Negative e to negative.
So it's just going to be negative. And then if I were to plug in 2, let's say, what is the sign? Positive. So I'm going negative to positive. So what does that mean? I have a min or a max? So I have a min at x is equal to 1. If I plug in 1, f of 1 is equal to 1 times e to the 1, which is just e. So officially the min is at the point 1e. So as far as that particular topic, just because we're close to lunchtime, hallelujah. I would say look at 1 and 3 would be similar to what we just did. If you want to try one on your own. And then tomorrow we'll do the concavity problems and points of inflection at least, and probably go ahead and do a second derivative test. I know it's kind of a lot to do at once, but like I said, it's not bad. It's just kind of tedious stuff. This is really just combining everything we've done to this point, so.